All right, right now we're going to look at the tools for this lathe. This is our new lathe. It has an indexable tool post, meaning if you wanted to move the tool around, you don't have to, once this is down, you don't have to remove that. You just back this off. It indexes all around to these teeth, and you can move it every number of degrees you want. So please don't keep backing this off and swinging the whole tool post around. It just stays where it is. Tightens right up. It's not going to move. We're going to go through these tools. He's a right-hand tool that will cuts towards the left. This front tip, that's upside down, that's sideways, and that's sideways. The insert is always up, is visible. So gold is always up. Whoops. Now this, when you're putting this in, try to choke up on it as tight as possible. We're not going to go like this, because if you have any problems, it'll shear that right off. It'll vibrate, it'll choke up. If you run out of range in here, I know you'll have to either come out, but just make sure you don't hit anything, the tailstock when it's in there, but tighten that up. We're going to cut from here this way with this tool. It's a nice sharp tool. Now when this gets damaged, you just loosen off this little torque screwdriver and turn this insert from here to here. These two can also be used, but it's a different tool holder. So you got 4 points on here to use. Sometimes you have 8, the bottom half too, depending on what type of tool you have, but there's 4 here.
That's considered indexable.
Indexable inserts. This one is a nice, it would give you a nice 45 if you want to put a chamfer. As you can see, this edge here give you a 45. And then the parting tool would give you, you can get that clearance in there. These like to be cut straight in. When you finished, if you want a 1 or 2 or a 5 thou pass this way, would clean that all up without damaging that insert. They have to be always at center height. I mean, I can't even think of a time when you wouldn't have this at center height. And if it's too high, exaggerated, you can see how the cutting edge is not going to hit the part and it's going to rub. If it's too low, the cutting edge is under the bottom. This piece is going to try to climb up on top and it's going to vibrate. If it's a smaller piece, it'll just actually break right off. This is the height adjustment. There's several ways of finding the center height, right to the point of just using your eye. You can use the center, the point on the tailstock. Come over this way, and you can set it up this height, which obviously is a little that way. Once you have that set up, this little locking nut can be just pinched off, so when you take it out, it doesn't move. Next time you put it back in, it's on center height, bearing the fact that this tool is the same width. We have many different heights of tools here, so if you're going to get set up for a job, we have 3 holders. in industry, you would have all your holders set up. You can have a parting tool, a right-hand tool, a threading tool, and the 45 tool, even a profiling tool. And this is a profiling tool. Every time I grab onto the cupboard, it's broken. And the reason it's broken is they don't like to take a lot of load. They take a little fine pass, so if this was on a CNC, or you would touch and it would go along here. After you've taken most of it down, your part, minus the thread, all down, this would come in, take it down, maybe a 10th out pass, drop in here, come across, come out, and profile the whole thing. It's got a nice sharp point, so you can get into corners. I like them in here, and we use them a lot here because you can actually get in here when you have your center going. Get right inside close if you want to turn smaller stuff down. They don't take a lot of load. Don't load them up. The threading tool is insertable. There's three different insert points, and as you can see, that cuts the thread. These have only a certain range. This one, I believe, only goes up to 10 threads per inch, and after that it's starting to hit this little wiper here, and it's in here hitting. So when these get ordered as a 10 pack, it'll have a range of 5 to 8 or 10 to 20. It'll say on the package what the range is, or you can just simply grab your thread pitch mic, which this isn't, it's a fishtail or a center gauge, and find out what tool it is. It usually says on the code. The knurling tool, and these are straight knurls actually. There's a fine, there's a medium, and there's a coarse knurl. This is a straight knurl, not a diamond pattern. The other one's in the cupboard. Grabbed the wrong one. It floats, but it's best, and if it wasn't exactly on center height, it would float, but it's best to have this center height on the center height. These take a lot of pressure, so if you're gonna knurl, remove the live center and put the dead center in with some grease, because the little needle bearings in here, and precision needle bearings, if you put a lot of side load on it, you're going to take them out, ruin them, wear them out much faster than you should. So this dead center, because you basically knurling is displacing metal. It's pushing it out of the way. It's not cutting, and it's forming it in here, and it puts a lot of load this way on it, which is hard on. A little bit of grease. You can see these, it's hard on these tips too, but this center is a lot cheaper to replace than the running center with the bearings. The left-hand tool starts on the left and goes to the right. You can see that. There's no way you can go here. This sometimes gets in the way if you're getting in. As you can see, even when you come down here, get in, then you swap out, you put this tool in, you can do that, come across, take that out, then you can thread. If you need a nice little chamfer on here when you're threading, if you don't chamfer it, it has a really sharp edge, it's almost like a knife edge, so you can put a good chamfer in there, and that lead in will be a chamfer. Usually this is 45, you put a 60 degree. Sometimes you can take the threading tool, if it's a bigger one, and put a 60 degree chamfer, so that now the lead in is 60 degree too. Anything else, Dave, I missed?
Depth of cut for these tools. I guess it depends on what you're...
It depends on the material, how close you to chuck, how rigid everything is. This tool, if it's a leaded steel or even a half-hard 4140, 100 thou, 150, even 200 thou you can do. You got to play around with the speeds and feeds. This one, they don't take a very heavy cut. that you can see too. It honestly, aluminum, you can really bear it. If you go heavy cut on aluminum and go too slow, it's going to start piling up. If you don't use, if it's a really soft, if you don't use coolant or a cutting oil, the aluminum will build up and there, almost weld right to it, and then it'll just tear everything up. So the cutting speeds and feeds, if you follow the cutting speed times 4 over D, and the rule of thumb is if this is a 16th thou radius on there, it looks like more like an 8. If that's, and on the code for the inserts on the box, it will tell you what the radius is. If it's a 16th thou radius, then you set your gearbox to 8 thou per rev. So the idea is you're taking half that rev and it's got time to come around and cut. If you're plowing past the diameter of the radius, it's going to start piling up on you. So I always start at half the nose tip for a feed rate, and then you can work up or down from that to get you better numbers. The other thing is, and this is my pet peeve, when I come up to the lathe, and this chuck key's here, this one, this is not right. It has to go in and has to be tight. If you just keep using this, you're going to round these edges over, you're going to round this over, and everything is just not going to work in time. It's just going to wear it out with time. So if you come up and it's this much play, please try to find the right chuck key. And if it is the right chuck key, just make sure it doesn't migrate to another machine. And we're running around trying to find the chuck keys, the right ones. But that's how that is. This belongs here. If that is, say, if these are, what would that be, like a 10 millimeter hex, don't put a 3/8 hex in there. It'll fit, it'll be loose, you'll wear the hex key out and you'll wear those screws out. When you put a wrench on or an Allen key on, it will fit right. Especially if it's a new machine, everything fits nice and tight. If it doesn't, then you have metric to imperial or imperial to metric. As you go further on, that is going to be your job, to know sizes, to know tools, and you have to start learning now and get everything, just play by the book.